Hello friends, this is your MCP Tutor and this is our second video of the channel and is about the gravity series. As you know that our last video is acceleration due to gravity, which is also a part of gravity. If you hadn't seen that video, I have linked it in the description below. So in our second video, we'll be dealing about escape velocity, which is also a major concept in gravity physics as well as rocket science. So about what is escape velocity, its representation and its diagrammatic explanation will be shown to you in a couple of minutes. So today we'll be focusing on to calculate the acceleration due to gravity of two planets, that is namely Venus and Uranus. Now I have chosen these two because as you know that Venus is the hottest planet in our solar system and Uranus is the coldest planet of our solar system. So it may be a good contrast and also a new and innovative idea and calculation to do in your homes. So let's get into the video, but before that don't forget to like this video, share it and also subscribe to my channel to get more content like this. Remember that every subscribe that you do for me is a motivation for me to post many such videos. So guys, first, what is escape velocity? What is the definition of escape velocity? What does it mean by escape velocity? The definition is given in the board, but I'll try and explain it to you in simple terms. Now, let's take this pen for example, and I need to throw this pen at a particular speed, a particular velocity to make it reach or escape the Earth's gravitational force by a hole. That required velocity or that particular velocity is known to be as escape velocity in simple terms. Now the definition also states the same but in a hi-fi way. So they tell us that escape velocity is the minimum velocity, is the particular velocity, in other words, required by a non-propelled body, a body which is not being pushed by another agent, to escape the gravitational sphere of influence of a celestial body, to escape the force of gravity of a particular heavenly body or a celestial body. So this is the diagrammatic representation of the same. So here it tells that there is a rocket standing at rest in this particular celestial body. So to escape the gravitational sphere of influence of that celestial body, it needs to gain a particular velocity and then move forward or on a circular path to get out of its gravitational sphere of influence. Now the body can reach out of the gravitational sphere of influence in many directions, such as going straight through it, cutting the atmosphere and going, or taking a circular path, doing a Hohmann transfer and getting out of the gravitational sphere of influence of that celestial body. So escape velocity is basically just the velocity needed or to be gained by an object to escape the gravitational force of that celestial body once again. So that is the introduction about escape velocity. Now let's go into the formula and the explanation of the equation. So here's the equation, friends, about how to calculate the escape velocity. So VESC, or in short escape velocity, which is written as V to the subscript lowercase esc, is equal to the square root, and the symbol of square root is given here, of, in brackets, 2 times the universal gravitational constant, or 6.67 into 10 to the power minus 11 Newton kg to the power minus 1, multiplied by the mass of the celestial body, or the mass of the first object, whole divided by the radius of the celestial body or the radius of the object. So this is the formula or the equation to calculate the escape velocity of any celestial body if you are given the mass and the radius. So here's our highlighted question of the day. That is the first question about calculating the escape velocity of Venus, whose mass is 4.867 into 10 to the power 24 and its radius is 6.051 into 10 to the power 6 meters. So if we plug in these values, if we substitute these values to our equation, then we might get the escape velocity of Venus is equal to 2 into 6.67 into 10 to the power minus 11, the universal gravitational constant, multiplied by the mass of the first object, mass of Venus, which is 4.867 into 10 to the power 24, whole divided by their radius, 6.051 into 10 to the power 6. So we have got the first step of doing our equation. So next we will separate the exponential part, the exponential terms, from the numerical terms. So to do that, we should perform all the required operations with the exponents and take them to the last. So multiplying exponents is the same as adding them according to the law of exponents. So minus 11 plus 24 is 24 minus 11, as we all know. And when we take an exponent from the denominator to the numerator, it itself becomes minus. So this gives us that 10 to the power minus 11 minus 6. So we can do it as in the same order, or 24 minus 6 plus 11, or 11 plus 6. It's the same answer. So next we can write it as the escape velocity is equal to the square root of 2.667 2 into 6.67 into 4.867 into 10 to the power 7. So 24 minus 11 plus 6 is equal to 24 minus 17, which is equal to 7, whole divided by 6.051. So the next step is a little bit tricky. Make sure you learn that well. So first, let's also take the square root of the exponential term, that is 10 to the power 7, the square root of 10 to the power 7. So the square root of an exponential term is the same as the exponent divided by 2. So 10 to the power 7 divided by 2 is equal to 10 to the power 3.5. That doesn't sound proper. So to make this a even number so that it remains a whole number after dividing it by 2 is by two ways. Increase the value of any of these terms and decrease the value of the exponential term, or increase the value of the exponential term by decreasing the value of these three terms, one of these three terms. So I feel it better that first let's perform 2.2 into 6.67, which is 13.34, multiplied by 4.867 whole divided by 6.051. So now if we take this decimal place one place to the left, it becomes 1.334 into 10 to the power 8. As we all know, as we decrease the value of one term, the exponential part increases. So this is how we do that. So we can next say that the escape velocity is equal to the square root of 1.334, as we have done here, into 4.867 divided by 6.051 into 10 to the power 4. So 8 divided by 2 equals 4. That's how we do that, finding the square root of exponential term. Next, leave this exponential term aside, ignore it, and our next set of problems would be solving the numerical terms, that is the 1.334 into 4.867, which is equal to approximately 6.426571 divided by 6.051 into 10 to the power 4. So the escape velocity is then equal to, so the square root of, so 6.426571 divided by 6.051 is approximately, so let's change our answer to approximately 1.6020 into 10 to the power 4. So that is the square root of. Next, the next step is a little more trickier. So the square root of 1.6020 into 10 to the power 4 can be done by multiplying 10,000 to this, or by finding the square root of the numerical part and multiplied by the exponential part. So I'm going to do the same. So finding the square root, 1.6020, let's group these values, and then 1 1 0, add them to bring. Oh, I have made a little mistake here, because 6.426571 divided by 6.051 is 1.0620. I am really sorry, I have mistaken it there. So now if we change this, it's 006, and we know that it can't be done, so it is 0 itself and then 20. Now 620. If we bring the 20 down, so 203 multiplied by 3 is 609. But if we do 4, it will go above 800. So this is our final answer with the difference 11. So let's plug in 3 here. So I think it's more consequenceable if we stop it here than continuing. If you want to continue, if you want a more accurate answer, just add 2 zeros here and continue the process all the way down. But I'll stop here. So we are left with the square root of 1.0620 as, or the escape velocity of Venus is 1.03 into 10 to the power 4 meters per second. So the SI unit of escape velocity is meters per second. That's why we have written this unit here. Or if you want the answer in kilometers, it's very easy to convert this answer. The escape velocity is equal to 10.3, that is increasing the value of the numerical part. So if we do this, it immediately the exponent becomes 3. And 10 to the power 3 meters is the same as kilometers. So our answer, or the escape velocity of Venus, is the same as 10.3 kilometers per second. This answer can also be checked in your web browser if you don't believe me. Anyway, moving on to our second question. So friends, this is the second question. Calculate the escape velocity of Uranus if its mass is 8.681 into 10 to the power 25. I have forgotten to write kilograms there. I'm sorry, and its radius is 2.53 into 10 to the power 7 meters. So I've done this problem already. It's the same simple terms of the last video. So first we should just plug in these mass and the radius's magnitudes to the equation, and then we should take the exponential terms at the last. So minus 11 plus 25 is 25 minus 11, and when we bring an exponent from the denominator to the numerator, it ultimately becomes minus, and 25 minus 11 minus 7 is 10 to the power 7. So again we should find the square root of 10 to the power 7, that is 10 to the power 35. That doesn't make any sense. So as I told you earlier, we should multiply 2 into 6.67, that is kind of a constant here, and then we should decrease the value of this numerical expression to get a higher value, that is from 10 to the power 7 we go to 10 to the power 8, and then we can simply divide it by 2 and 10 to the power 4, and then 11.58450 divided by 2.53 into 10 to the power 4. So finally the escape velocity is equal to 4.5776. So as I divided these, and also I got this product by multiplying 1.334 into 8.681. So that's 11.580450, and then as we divide we get approximately 4.55776 into 10 to the power 4. Find its square root. The method is given here. I'll put arrows because you can continue if you need a more accurate square, but I'd always hope that you finish it with the second decimal, that is 100 place, so that it doesn't go wrong. And then the escape velocity finally is equal to 2.13 into 10 to the power 4 meters per second. If we want to convert it to kilometers, as I have told you, take the decimal one place to the right it becomes 21.3. Then we get strike it and we can put it as 3. So 10 to the power 3 meters is the same as 21.3 kilometers per second. And that is today's video, that is today's episode, and this is the end of the gravity series. Next, the upcoming series are electromagnetic and electrical series. In that we'll be dealing about many laws such as Faraday's law, Coulomb's law and Ohm's law, but that's a story for another video in this channel. We would also be dealing with the forces series, in which we'll explain all the 3 types of motion of type 3 laws of motion, and even that's another story for another video. So I think you like this content, and if you did, please share my video, like it and subscribe to my channel. Thank you, friends.